Right, so in this video I'm going to look at integrating a function by first performing partial fraction expansion. So I'm going to have a look at a particular indefinite integral, and that indefinite integral is the integral of 7x plus 6 over x minus 2 times x plus 3 dx. So what we're going to do is perform partial fraction expansion first, and then we're going to do the integration. So let's just do the partial expansion. So what that means is I'm going to take this fraction here, I'm going to take 7x plus 6 all over x minus 2 times x plus 3, and I'm going to split it up into two fractions added. So in other words, I'm going to take this fraction here and I'm going to put some value we'll call a over x minus 2 plus I'm going to take some value b, and I'm going to put that over x plus 3. So I'm going to split this fraction up into these two fractions here, and you can see that the common denominator for these two fractions here will just be the two denominators multiplied, x minus 2 times x plus 3, which is what we've got here. And really what I've got to do here is solve for a and b, find what a and b would be in order for me to get a 7x plus 6 on the top here. So let's just work that out. So first thing, I'm going to start here on the right hand side and I'm going to solve for a and b. I'm going to add these two fractions first, so let's just move it over here. So I'm going to end up with, in other words, the x minus 2 on the bottom times x plus 3, which is what I want here, and the top will become, well, it'll become the a times x plus 3 here, because I have an x minus 2 divided into this here will just leave me with an x plus 3, multiply the x plus 3 by a, so I end up with a times x plus 3, plus, and then I'll have the b here, and that will be times x minus 2. Okay, so if I just continue that on, then let's just multiply out the top line here. I'll end up with ax plus 3a plus bx minus 2b, and then on the bottom here I'll still have the x minus 2 and the x plus 3. Okay, now this here, I want this to be equal to this here, this 7x plus 6 over x minus 2 x plus 3. So we can see that the bottom two parts are equal already, so that's fine. So really I need the top part to be equal to the top part here. So really what I need here is for the ax, I'll put the x's together here, ax plus bx plus 3a minus 2b, I need that to be equal to 7x plus 6, and I need to solve for a, what would a and b be to give me 7x plus 6 here. Well, I can factorize out the x's here anyway, so that will just give me a plus b times x, and here I'll just have 3a minus 2b. This bit here, they have no x's, so that's just equal to 7x plus 6 here. Now if you look here, I've got something times x plus a number. Here I've got some numbers times x plus this here, this is a constant here, there are no x's here, so the 3a minus 2b is the constant part of this expression here, if you like. So I can equate coefficients here. I can equate this equal to the 6 and this a plus b here equal to the 7, which is what I want. I want, in other words, a plus b to be equal to the 7, and I want 3a plus 6, 3a plus 6, no, sorry, 3a minus 2b, sorry, let me just go back here, 3a minus 3a minus 2b, I want that to be equal to the 6. Okay, so I have two equations here, two unknowns, so let me just call this equation 1, this equation 2. What I've got to do here is solve for a and b. So I'm going to take equation 1 and I'm going to multiply it by 2. So that will give me 2a plus 2b is equal to 14. So if I just take these two equations now, equation 1 and 2, and just add them, here I'll end up with 3a plus 2a, that gives me 5a, minus 2b plus 2b, well that will just cancel to give me 0, and here I'll end up with 20, so that will just give me an a here equal to 20 divided by 5, which is 4. So I can see here that a plus b is equal to 7, that's equation 1. We now know what a is. A is 4 plus b equal to 7, so that will just give me b is equal to 3. So now I know what a and b are. So if I could just go back up here again, this is what I wanted. I wanted this fraction here to be split up into two different fractions. Now I just put in a variable here, a, which I didn't know, and a b here as well, which I didn't know. I've worked out that a is now 4 and b is 3. So let me just rewrite that. So remember what we started with here was the integral of 7x plus 6 over x minus 2 times x plus 3 dx. I now know that that's exactly the same as the integral of 4 over x minus 2, my a was 4, plus my b was 3 over x plus 3 dx. Now you can check this if you like. You can just add these two fractions and you should end up with this. I'll just do a quick check here. Let me just take these two fractions here. So I have 4 over x minus 2 plus 3 over x plus 3. Let's just add these two fractions. Well, my common denominator here is x minus 2, x plus 3. Well, x minus 2 into this here will give me x plus 3, so I end up with 4 times x plus 3, plus x plus 3 into this here will give me x minus 2, so it's 3 times x minus 2. Multiply out the top, so you get 4x plus 12 plus this is 3 here, 3 times x, 3x minus 6. So if that's all over, x minus 2 times x plus 3, and if I just do at the top line here, I get 4x plus 3x, that will give me 7x. 12 minus 6 is plus 6, and on the bottom here I end up with x minus 2 times x plus 3. So I end up with 7x plus 6 on the top when I add these two fractions here. So they are exactly the same here, 7x plus 6 when I add these two fractions here. So that's fine. So now all I've got to do really is just find the integral of these two expressions here, rather than this complicated looking expression here. So let's just do that. Well, the integral of two things added is just the integral of each one and then add the integral. So in other words, it's just going to be equal to, just do this in white here, so it's going to be equal to the integral of 4 over x minus 2 plus the integral of 3 over x plus 3. Now the integral of 1 over x, the integral of 1 over x is log x, so the integral of, if you like, 1 over x minus 2 is going to be log x minus 2. We also have this 4 here, and then over here we have the integral of 3 over x plus 3, so that's going to give me 3 times the log of x plus 3. Okay, so really that's it. Oh, and we also have our constant of integration here as well. So that's really it, using partial fractions to split up a fraction into two different fractions added or subtracted, and then you can perform the integrals on each individual part. Okay, and that's it for this particular video.